Welcome to this introduction to Google Kubernetes Engine. Commonly known as GKE, GKE is Google Cloud Platform's managed Kubernetes service that allows you to run containerized applications at scale. This is part of our GCP Containers Series, where we explore how Google Cloud helps you deploy, manage, and orchestrate containers efficiently. Throughout this video, we'll explore what GKE is, how it works, and why it's become a popular choice for organizations running containerized workloads in the cloud. Google Kubernetes Engine is a fully managed Kubernetes service that runs your containerized applications on Google Cloud infrastructure. What makes it managed is that Google handles all the complex control plane components and system upgrades for you. This means you don't need to worry about maintaining the Kubernetes master nodes or ensuring they're highly available. GKE also provides auto-scaling capabilities, which means it can automatically adjust your cluster resources based on the actual demand of your applications. This helps optimize both performance and costs by scaling up when you need more resources and scaling down when demand decreases. The architecture of GKE consists of two main components. First is the control plane, which is the brain of your Kubernetes cluster. It includes critical components like the API server, the scheduler, and various controllers. The best part is that this control plane is fully managed by Google, meaning it's always highly available and you never have to worry about maintaining it. Second are the worker nodes, which are the actual compute engine virtual machines where your containerized applications run. These nodes host your application workloads and are configured and managed through GKE, while Google manages the control plane automatically. You have control over how your worker nodes are configured and scaled. GKE offers two distinct cluster types to match different operational needs. Standard mode gives you full control over your cluster infrastructure and node configuration. With standard mode, you manually manage nodes, choose custom machine types, and have maximum flexibility to configure everything exactly as you need. This is ideal when you need fine-grained control over your infrastructure. On the other hand, Autopilot Mode is a fully managed experience where Google handles almost everything for you. In Autopilot, node provisioning is automated. You pay only for the resources your pods actually use, and operational overhead is significantly reduced. Autopilot is Google's recommended approach for most workloads because it simplifies operations while still providing enterprise-grade capabilities. GKE comes with several powerful features that make managing Kubernetes clusters easier. Auto-repair automatically detects unhealthy nodes and repairs them to maintain cluster reliability without manual intervention. Auto-upgrade keeps your clusters current with the latest Kubernetes versions and security patches, ensuring you're always protected against vulnerabilities. GKE has built-in security features including workload identity for secure service authentication, binary authorization to control which container images can be deployed, and many other security capabilities. Finally, GKE integrates seamlessly with cloud monitoring and cloud logging, giving you comprehensive observability into your cluster's health, performance, and application behavior. Creating a GKE cluster is straightforward using the gcloud command line tool. The basic command is gcloud container clusters create, followed by your cluster name. You specify the zone where you want the cluster deployed using the zone flag. The numNodes flag determines how many worker nodes your cluster will have, and the machine type flag lets you choose the compute engine machine type for your nodes. In this example, we're creating a cluster called myCluster in the usCentral1, a zone with 3 nodes of type N1, standard 2. This single command provisions an entire Kubernetes cluster for you, with Google managing the control plane automatically. Once your cluster is created, you need to connect to it to start deploying applications. The gcloud container clusters getCredentials command retrieves the authentication credentials and configures kubectl, the Kubernetes command line tool, to communicate with your cluster. You specify the cluster name and zone where it's located. After running this command, your local kubectl is configured to interact with your GKE cluster. To verify the connection is working, you can run kubectl get nodes, which lists all the worker nodes in your cluster. This confirms that kubectl is properly configured and you're ready to start deploying applications to your GKE cluster. There are several compelling reasons to choose GKE for your Kubernetes workloads. First, it significantly reduces complexity by eliminating the need to manage Kubernetes control plane infrastructure and updates. This lets your team focus on applications rather than infrastructure maintenance. Second, GKE helps optimize costs because you only pay for the worker nodes you use, and auto-scaling ensures you're not over-provisioning resources. Third, GKE provides native integration with other Google Cloud services like IAM for identity management, cloud storage for persistent data, and BigQuery for analytics. Finally, GKE is enterprise-ready with production-grade security, compliance certifications, and a 99.95% uptime service level agreement available. This makes GKE suitable for running critical production workloads at any scale.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.